Hello, everyone. This is Professor Maloney doing my last overview session for this class. So if you've made it this far, then you're in, hopefully, please God, you're in great shape. The last chapter for our class is Unit 8 or Chapter 8, and it covers arrays. So what is an array? Well, every class or every chapter that we've been going through, particularly once we got to chapter 4 when we started using logic statements, everything is sort of built upon itself in a real good logical progression, if you will. So you can think of an array as a structured data type as opposed to a simple data type, but the structured data type can then have hundreds, thousands, tens of thousands of array elements, with the understanding, of course, that the array with the structured data type means one data type. As an example, you can have an integer, you can have a double, you can have a string, and then if you're going to do it with an array, you have a left and right bracket on it and the number of values in between those brackets, although you can also declare them after the fact. If you just have a declaration int tests, left bracket, right bracket, that would be an array called tests with integer data type, but at some point you would have to assign via an argument the number of tests that you're going to allow, meaning test scores, I guess in this case, that you're going to allow. So they're really huge in programming. A lot of things we did in chapter 5, or again, unit 5, where we were doing for loops and while loops and do while loops even, could be done much easier in terms of code statements, how many code statements we ultimately have using arrays, okay? So arrays work though in conjunction with loops for the most part, because we want to cycle through all these records that we're allowing to be processed as part of our array. All righty. So now a couple introductory things before we get going, but in terms of the rest of the class. So understand this, okay? And let me start sharing my screen now rather than me. All right, so let me share my screen and share. All right, and now so I don't have to look at that page, let's go over to my mail page. All right, so now let's hide that though. I mean, hide the bottom thing. So let's look at my calendar over here. All right, so this is November 29th. So tomorrow will be, well, tomorrow when I say hi to you in class, it'll be today at that point, the 30th, the last day of the month. But in any event, all I'm doing is showing you how many days are left for you to do your work. Remember, there's 2 units in this chapter, Unit 7 and Unit 8, okay? So what do we got? We have the 30th and the 2nd this week. The 30th is November, and the 2nd is the first class day of December. So that's 2 more days, all right? Then the week after that is December the 7th and December the 9th. That's now a total of 4 days. And December the 9th is the last class day of week 16, which means you cannot submit any assignments after 11:59 p.m. on December the 9th. Understand that, guys, okay? I try to be very fair in this class, and God knows how many times I've asked you, do you want to make any assignments up? Let me know. If you missed an exam, let me know. I do my best to give you all the information I can. I've created 20 or more videos, actually at least 25 probably videos for this class with a bare minimum length of like 30 minutes, and most are in the 40s or 50s or 60s or 70s of minutes, meaning over an hour in many cases. And yes, I acknowledge they're not the best, but they are my version of giving you as much hands-on as I can, and at the same time giving you lectures because I'm not seeing you in person, so that you can at least watch these over and over as is necessary. All right. Now, so what I want to say is this. For those of you that have not started units 7 or 8 in terms of programs, you only now have until December the 9th. So I'll pretend it's tomorrow, which is today when I say hi to you tomorrow. So hey, students, today is Tuesday, November 30th. There are only, and of course I'll say that day's over because it's already started. So I'll say there are only 3 more days to go. Thursday, December 2nd, Tuesday, December 7th, and Thursday, December 9th in terms of, not for the entire class, but 3 days, class days, for you to finish all the Unit 7 and Unit 8 exercises, programming exercises, plus those 2 quizzes, the Unit 7 quiz, the Unit 8 quiz. And Unit 7, as I said quite a few times in the last couple weeks, there's only 5 programming exercises, and then there's the usual 6 for Unit 8. So you have a total of 11 programming exercises, making the assumption you haven't started any. For some of you, thank God, you're already in Unit 8 work. So you're doing very, very well, okay? So again, this point is just to remind you that there are literally only 9 days for you to do all that work, assuming you are behind in that work. If you want to make up anything that you've previously missed, you can also make it up, but still nothing can be submitted past December 9th. Why? December 9th is officially the last day of class. We don't count finals week as a week. It doesn't count as a class day. It's an exam day based upon the final exams schedule. Class is over because this is a Tuesday, Thursday class. It's not an MDC online 7-day-a-week class. You do things whenever you want. It's a MDC live class following the schedule, same schedule as if I was teaching this class face-to-face, in which case Tuesday and Thursday are your class days. So Thursday, December 9th, that's it. Okay? Do not send me an email Friday morning, December 10th. Professor, please, 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 I have never bothered you before, or please, 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 I know I've been behind, or please, please, please. No, the answer will be no. Okay? I have not given the answer of no virtually the entire term. Okay? I haven't even modified my 20% late penalty for the many times I've been asked to let somebody make up an exam or make up some programming exercises from earlier chapters, earlier units. So I'm not trying to beat you up now either. I would like you to do your evaluations, by the way. So if you want to beat me up, there you go again. But have I told you how you're doing in this class? Have I told you? If not, weighted total, I've talked about it for sure. Your weighted total class grade is in Blackboard. MindTap is not your weighted total class grade. I keep telling you, look at your My Grades in Blackboard. In your Blackboard My Grades area, you'll find this class. And then look for all the grades. And weighted total is the average you get based on 8 points that you were given, up to 8 points for your 8 quizzes in the class, 2 points for your bio. So 2 and 8 is 10. 3 exams, 20% each, so that's 60 plus 10 is 70, and 30% for the 41 or so programming exercises. So 90% of your grade comes from your exams and your programming exercises. Everybody knows that. I have talked about it innumerable times. So if you talk about that in your feedback, hopefully you agree that Professor Maloney has done so. Anybody that has sent me an email in this class, anybody, you have never, ever waited 24 hours to get an email response from me, ever. If you want to challenge me on it, tell me when you sent me an email and I'll tell you the minute I replied. Okay? And again, I'm not trying to defend myself. My job, in my humble opinion, is always good. But regardless, do your student evaluations, right? That's the point. Finally, if anybody in this class that's in good shape, meaning he or she has completed their units 7 and 8 work, or perhaps they'll finish them in the next few days. Well, then if you want to take the exam early, you can get with me and I'll come up with something and let you take it early. Okay? All right, rock and roll. All right, so now I'm going to do my Unit 8 overview. I'm not going to cover everything. I'm going to try to show you what you need to do based on what you have to do in the programming exercises for Unit 8. All right. So I already have up MindTap right here. So in MindTap for Unit 8, okay, we have the code. Now, you can see actually only one person really has submitted the first 2 programming exercises and the 5th, okay? Nobody has submitted exercises 3, 4, or 6. So 1, 2, and 5, one person. That's not a lot out of a class this size. So please, please understand what you've got. And let's just go up one more time and look at 7, even though I don't want to, because I was hoping we would be in much better shape now, but I've already previewed it just to let you know. So 9 people, and it's now 20 or 21, I forget the number in the class, but it's either 20 or 21. So the percent is basically 41. It's technically either 43, 45, or 46, depending on if it's 20 or 21 students. But either way, 9 of you have done number 1. Only 3 have done number 2. Only 3 have done number 3. Only 5 have done number 4. Only 1 has done exercise 7-5. Okay, the last one for this particular chapter or unit. Okay, now remember, I gave you 7-1. I gave it to you. Okay, and only 9 of you have done it based on what I gave you. And then I did either 7-2 or 7-4. I forget which one now, but one of these 2, and only 3 and only 5 respectively have been submitted by you guys. So again, you know, you have to do your part, right? So understand that you got a lot of work to do. But opening up my calendar one last time. So what is, again, the way it goes? So where we are, 30th is my chapter 8 or unit 8 overview. Okay, that's today. We're saying it's the 30th. Then the 2nd, I'll be giving you a program that will demonstrate either 8.1 or 8.2 and 8.3. 8.2 is doing an index looking for the littlest item in an array. And then the next one, 8.3, is looking for the biggest item in an array, or vice versa. But if you can do the smallest index, then you can do the largest index. It's literally the same code, just modifying it so that you're looking for a different value, right? The smallest versus the largest, okay? So 2 of these 6 will be done with one programming exercise that I will demonstrate for you. There's also, though, in this chapter from 8.1 to 8.6, a string function, one more time with a string function. There's one value that you're using an in file, meaning a data file, and that may actually be 2. But I'm going to click on all the things today and tell you what you need to start looking at for it, okay? Even before my PowerPoint presentation. All right, so now, and by the way, I'm going to be looking in the full book to show you a couple pages I want you to start looking at. All right, so that's that. Now what? Yeah, so I'll just now go into Unit 8 and just give you a quick overview on what you're doing for these programs, all right? So exercise 8-1, programming exercise 8-1, of course, that means. Really, I should have started with either 8.2 or 8.3 because they're easier than 8.1. And again, I've said over and over again that they're not in a sequential order from easiest to hardest. Many times 8.1 could be, or any first exercise could be the hardest. The 6th could be the easiest, vice versa. Any in the middle, whatever, right? But so write a C++ program that declares an array of 50 components of type double. So in this case, the way you declare an array is double space array name, which would be alpha, okay, left bracket, right bracket, and then 50 in between, okay? That declares an array called alpha, lowercase alpha, with 50 components. The 50 components go from index value 0 to index value 49, just like we've talked about over and over and over again in this class. Everything in computers starts at 0 unless you're doing a length of anything, then it starts at 1. But you can modify all these zeros to start at 1, but normally we don't do that because the logic is there, and when we need to convert it to something, we can start it at the 1 or just do a +1, you know, to the index value. But anyway, so that's declaring an array. Okay, that's easy. But initialize the array so that the first 25 components are equal to the square of the index variable. What is the index variable? Remember I said when you have an array, like double is the data type here, what we're doing is we're going to get 50 numbers that are all double. Okay, you can't have a string, you can't have an int, you can't have anything else. Everything is double. Okay, so when we're taking these values, let's just say they go from 0 to 49. So it's 50 items, all numbers, obviously, because of the word double. And for the first 25 of these numbers, and remember, first index is 0, all right, which means last index is 49. So when it talks about the first 25 components, that means values 0 through 24. And for those first 25 values from 0 to 24, you're going to take the number, meaning the 0, and square it. So 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. Up to 24 squared. Let's see, 24 times 24. So 10 times 24 is 240. Another 10 times 24 is 240. It's 480. And then 4 times 24 is 96. 480 and 100 would be 580 less 4. 576 would be 24 squared. All right, that's going to be those values. Then, you're going to use a for loop to do those. In all likelihood, you would do that. Okay, a for loop to do those. And then you're going to take the next 25 components, because remember there's 50. So then basically you're going to start this one with the for loop, starting with the index value of 25 and going up to 49. And for these, what you're going to output to the screen, and the other one you're outputting to the screen as well, but via a function, a print array function. So you're going to go from 25 to 49. And in this case, you're going to just take the number times 3. So 25 times 3 is 75. The next value, 26 times 3 is 78. The next one, 27 times 3, that's 81. 49 times 3, well, if it's 50, it's 150. 150 less 3, it's 147 for 49 times 3, okay? And then you're outputting the array so that 10 elements per line are printed, which means you'd have 20, 20, and 5 for the first set, and then 10, 10, and, did I say 10? 10, 10, and 5, meaning 3 lines with the 10 values, next line with 10 values, and the third line with 5 values for this first loop. Then for the last 25, another 10, okay? So 10, and then another 10, 20, and then another 5, okay? Is what you're doing. And how do you determine whether it's 10 elements? Remember, that's modulus math, right? If you got 50, so 10 is going to say, uh-oh, 10 is here. So if the modulus is 0 based on, int math with 10, the number 10, then you're going to get an occurrence at 10. So then you switch lines. Then another occurrence at 20, so you switch lines. Another occurrence at 30. So technically, actually, with the 30, that would mean you'd have 5 from the first. So it's not really what I said, 10, 10, and 5, because I'm reading it now. So it would be 10, meaning 10 numbers from 0 through 9, where you're squaring them all. So 0 is 0, 9 is 81. So those first 10 are on one line. Then it's going to go from 10, which is 11, because remember it's 0 base. So it'll go from 11 up until 19, okay? And then those 10 will be on the next line. So that would be 11 times 11 is 121, up to 19 times 19, which is, so 20 times 20 is 400, less 19 is 381, unless it's less 38. I think it's 381. All right, so 19 squared would be 381. Then you're going to also, though, have in the third one 5 more from the next set of numbers. But don't worry too much about this yet. First, you worry about doing your arrays, right? So anyway, you're going to have basically, I guess, 5 lines of output. The first 25 or the first 2.5 lines are going to have each index value multiplied by itself. And you're going to obviously count that via a loop, and then just put a coot to the screen to do it, but that's going to be in the print array. Then the next 25, as I just said, are going to be then, instead of multiplying them by, a square or a cubed or whatever, you're going to multiply the number times 3. So 3 times 25, then 3 times 26, 3 times 27, up to 3 times 49. Okay. All right. And then output the array so that 10 elements per line are printed. And then they show you what it should look like. Yeah, actually, that's what I should have looked at right here. So see, 5 lines of output. So 0 through, and these are this is the deck that you're going to actually get. It's not a deck per se, but so this shows me that we're doing the numbers consecutively. So you're going to have 50 components from 0 to 49. So there's no other numbers. You're not getting the input from the user. That's all you're doing. When you do the first half of the for loop is going to get you until, let's see, 576. Okay. So that is 25 numbers, because see, there's some that are hidden over here, right there. So that's 10. So from 0, 1, 4, 9, 16 up to 49 there. And then if you scroll over at 64 and 81. Well, you know 9 times 9 is 81. So, and the first one is 0. So 0 to 9 means 10 numbers are up there. Okay. The next one, 10 times 10. So you know you're starting at index 10, which is really 11. So 10 times 10 is 100. And then that's going up until 361. I don't think I know 361, but it's got to be a number like 7 to come up with a 1, or a 9 to come up with a none. That. So let's say it's 9, because it's probably that. So 19 times 19. Oh, I said 381. Maybe it's 361. However that works out. All right. But if you multiply 19 times 19, you'll know what the value is. Then the next 5. Yeah, because this is 20 times 20. So that's up to 19. So now it's 20, which is really 21. And so well, let's just say 20, 21, 22, 23, 24 is this one, 576, which is 24 squared. Okay, so that one. And then the first 5 of the next one. Remember, the next one starts at 25, not meaning 0 through 24, and then the next 25 start at 25. So 25 times 3, 75. 26 times 3, 78. 27 times 3, 81. And here I told you the last number, 49 times 3 equals 147. All right, so that's basically what you're doing in that one. It's going to take you 2 loops, if not 3, to do that. But again, this one is a little bit harder than the others, but it's still not much when I show you how you put index values together in arrays. All right, okay, so that's 8-1. It's going to take me the whole darn class overview to do this. But I want to show you these things to help you to get going on those that haven't done anything yet. So then the next one, 8-2, is really very similar to the next one after this, which is 8-3. So here, write a C++ function, smallest index, okay? And function, so you know function means we're going to have a function prototype. We're going to call the function from int main, and we're going to then have the function definition under int main. It's going to be called smallest index. What's it going to do? It's going to take as parameters an int array and its size. Sometimes when you declare arrays, you don't declare them with a size. So in this case, you're going to have 2 arguments. One argument is going to be the size of the array. The other is going to be the name of the array. It's not necessary to do it that way, but that's what they want to do for this example. All right. So in this case, though, it's going to return the index of the first occurrence of the smallest element in the array. To test your function, write a main, meaning an int main, that prompts a user for a list of 15 integers and outputs the index and value of the first occurrence of the smallest value. So in other words, in this case, you're putting a note to the user. Enter 15 integers with a colon, okay? Then you're doing a new line, and then down here, the user is entering his or her numbers. So they're going 1, 2, 3, 4, 5, 6, 7, 8, 9, but then instead of saying 10, they're going 0. So now we have a lower number, 0. And then 10, 11, 12, 13, 14. So they literally took the first 15 numbers except for 10. And they did put 10, I mean 10 through 14, but they don't have 15, and they didn't put the 0 at the beginning. So it's really 0 through 14. We can all see that, okay? So then they want you to output the information this way. So it says 0 through 14. You're listing, you know, your print array is going to list these to the screen. And then you're going to print out this sentence here, or this whatever it is, through the colon. So it says the position of the first occurrence of the smallest element in list is. So you're not going to put the number 9, but you're looking for the position of the first occurrence of the smallest element. Because see, technically the person could have input, as an example, these are the numbers. They could have input 0, you know, up here before 6 as well. or the number 14 could have been written up here where it says 2. So it could have been 1, 14, 2, 3, right? Especially when you have a lot of numbers, you can't tell if there's any that are repeating or not. So they want you to find the first occurrence, and it's telling us, again, so first of all, the smallest position, the position of the first occurrence of the smallest element. Position means where in the numbers out there are they? In other words, there's 15 characters, so you start here as 0. So 0, 1, 2, 3, 4, 5, 6, I guess you should do it this way, 7, 8, and this is the 9th character, okay? So the position is 9 based on, oh, sorry, it's 0 through whatever. I don't know what it, well, either way, it's 9. So that means it's 10. So if you count it as 0, 1, 2, that's 3. 0, 1, 2. Then 3, 4, 5, that's 6. 3, 4, 5, 6, 7, 8, that's 9. And then the next one is 10. So either way, you got to get to the 0. You know, you got 9 numbers right here, right? 9 numbers above it, that is. And then this is the 10th number. But because it starts at 0, the 0 here is position 9, not position 10. All right. So then you would put the position of the first occurrence off the smallest element in list is the colon. And then you're going to have a variable called smallest element or whatever, an integer value. And it'll be the number 9 based on what your loop is doing to find which one is smallest. And then it tells you the last thing they want you to put is the smallest element in list is. So again, you would type this part out in your coot, and then you'd put the value here for smallest index, or again, whatever variables you use, okay? All right, that would be that one. So, and this one here, and then here's their like test X. So 56, 34, see 56 twice. Here's a 56, here's a 56. If you find, in this case, the smallest element is what they're looking for, and they said the first occurrence. So if you get, let's just pretend there's no 34, no 15, no whatever. Let's pretend, because I see a 56 here and a 56 here. Just pretend as you're doing your coding, even though there's also actually a 54. So there may be a couple of lots of these numbers, but either way, if these were the first 5 numbers and the 56 was, let's say, 5 instead, okay? So 5, 34, 67, 54, 5. When you find the first one, it's 34. You're comparing 34 then, 5. I'm pretending the 56 is 5. So you would be first comparing it to the next index. So this is index 1, the 56. So let me do it this way. So this would be index really 0. So, and 0, we'll call it number 0. So number 0 is 56. Is number 0 less than number 34? Because you want this first. So if this is smaller, then we want to assign it to the smallest index. So it would be if it's 5, right? 5 is less than 34. So then you'd put 5 as the lowest number. Then you'd compare 5 to 67. Well, 5 is not, 5 is also smaller, than 67. So 5 is still the smallest number. And then here, 54. Yeah, 5 is smaller than 54. So again, it's the smallest number. But here, is 5 less than 5? No, it's not. No, it's not. But you would then still have, it's not smaller than, so it's not is the answer. So this one is still the winner, right? Because this one here is the first occurrence. And this one, we're not saying less than or equal, we're saying less than. And that's what you basically have to do is you're going through your loop, right? You're always having the index value or whatever you call the variable, and it's always going to be moving up by 1 each time. If these are 15 numbers, it's 0 through 14. So 0, 1, 2, 3, and I won't go anymore, 4, right? But you're comparing the first against the second. Then the smaller of those 2 against the third. Then the smaller of those 3 against the fourth. The smaller of those 4 against the fifth. Because whichever one is always coming over as the smallest is then compared against the new number is the real answer. And whichever one is the smallest index, and in this case, this one we're saying is a 5, so it would stay as the smallest throughout everything because we're pretending this 5 here, well, not pretending, but this one here that I'm also saying is 5 is equal to, but it's not less than. So this one would win. All right. Anyway, that's that one. Now watch the difference with that one and this one. So that's 8-2, and here's 8-3. 8-3 is the very same thing Very, very same thing. But now it's the last largest index. So there's two little differences. One is that it's the last. The other one wanted the first number. So here you want the largest, but the last largest number. You don't want smallest and you don't want first. You want the last and the largest. But it's the same thing. Enter 15 numbers. Same thing. 1, 2, 3. We're pretending these are the values, right? So that's 15 numbers, okay, that were entered. And in this case, they're literally the same ones we saw a little while ago, actually. The 0 is the smallest number here, but we want the biggest. And they're going exactly in order. 10, 11, 12, 13, 14. I cannot answer that, so sorry, let me. So anyway, this is the highest number, 14, all right? So we're saying here the position of the first occurrence. Oh, God. Excuse me. Okay. The first occurrence of the largest, the position of the first occurrence, the largest element in the list, okay? But wait a minute, that says first, and here they said last. Oh, no, sorry about that. It is the same, very same. So first occurrence of the largest value, okay? So the first occurrence of the largest value. So in this case, it's the same thing. The position of the first occurrence. So this is position, okay? It's 14. In this case, though, there's only one that is the value 14. So the number is 14. The position is 14. So it's kind of confusing because it's the same number. The reason it's again position 14 is because remember it's 0 based. So where it says 1, that's 0. So 2 is 1, okay? And 14 based on this, starting at 0. So 0, 1, 2, 3, up to here, it's 8. But then here it's 9 again because of the 0. And then 10, 11, 12, 13, 14. So 14 is the position number, but it's also the element value. So the largest element is the actual number. The position means where in the index. And it's 0 through 14, really, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then 10, 11, 12, 13, 14. So we know there's a total of 15 values based on that, right? Because every number is represented. The only one that's not in order is the 0. But if you put the 0 at the beginning, it's 0 through 14, nothing skipped. So therefore, the position for the value is 1 less than the number of values, right? So there's 15 values, so the position is 1 less than that, so it's 14, okay? But don't confuse that 14 with this one, all right? All right, so anyway, that's 8.2 and 8.3, and you can see they're the very same thing, all right? And I'm gonna be doing a programming exercise video on Thursday for sure, demonstrating using a smallest and also a largest value of some sort, all right? Oh, cool. All right, then 8.4. Well, I'm going to chop up the overview though. Now, I'll talk about some of the slides and then do whatever else. All right, write a program that reads a file consisting of students' test scores in the range 0 through 200. So normally tests go up to 100. In this case, oh, they have a data file in this one. Okay, so you're going to be doing an in file. Or, you know, you're going to be doing some semblance of what I would call an in file, and then creating maybe an out file. I'm going to do a total of 2 out of the 6. I mean, in a similar fashion as theirs. So, but I have to look at which ones make, you know, that I want to do for you guys. But basically, anyway, pretend this is 0 to 100 on a normal test, but they're saying this particular test, there's 200. So to get an A, they're saying you have to get 175 to 200. To get a B, I guess 150 to 174. To get a C, 125 to 149. To get a D, 100 to 124, and anything else less than 100, in their case, in this demonstration, would be an F, okay? So, and they're saying to put in these though, or let's see, this is the, okay, wait, let's see, that's main. This is the text file. So the text file, okay, are just those numbers. No, sorry. All right, the test file is the student's scores. So they go from as low as 12 to as high as 200, right? So they're going from 0, from 12 to 200. And again, well, here's another 200, same thing, but they're not basing this one on how many, who's the largest index. They're going to want you to run a program, okay? Output the score ranges and the number of students. Run your program with the following data. Let's do the check so I can see what your output would look like. Incomplete. Attempt it. Why can't I darn well? I don't know why I can never. I can't see it. Let me just look at the instructions a bit more. Write a program that reads a file. So it's reading a file. And you have the instructions on how to read a file. But again, depending, I am going to be doing one more program, even though the one I do on Thursday is going to give you two, the wherewithal or the ability to do two different programs, as long as you're paying attention and doing your readings and everything else in class. So it should then determine the number of students. Okay, here we go. They want to know the number of students having scores in each of these ranges. Okay, that's the part you're going to have to do. So based on just looking at it, what do you call? So we would want 175 to 200. So I'm looking for every number 175 or higher. Don't need to know the exacts. So here's 1, okay, 175 or higher. Here's 2, 175 or higher. That's 3, 175. That's 4, 175 or higher. So that's now 5. That's not. This one is now 6. This one is 7. That's not. This one is 8. I believe there's 8. So again, your way of doing this is you're going to be capturing, through either switch structure with case statements, which probably makes the most sense, and putting A as an example for numbers that are between 175 and 200. B, for example, for numbers that are 150 to 174, etc. But you have to just do whatever else they're asking you to do. But that's pretty easy, but you will be declaring an array. And I'm going to show you how to declare arrays a little bit more in our overview when I get to it. All right, so that's 8.4. 8.5. Write a program that prompts the user to input a string and outputs the string in uppercase letters. Okay. So in this particular case, let's see if they have an example for this one. Program. I don't remember what to do to see these things now. Let's just run the checks just to see. See if I then run something. I mean, be able to do it. Let's look now. 0 out of 2 passed, but I want to find out the details. Okay, so they're saying if I input the word jump, okay, so little letters J-U-M-P, all you got to do is output them as capital J-U-M-P, which basically means doing a .2 upper with whatever your variables are called here. So this actually may be the easiest. This probably is the easiest of the programs, okay? Because for sure, let's see if they're telling you any functions or any arrays. I mean, you have to do an array because it is this thing. And when you're talking about, yeah, you're going to, okay, they're saying use a character array. That's one thing I wasn't even going to talk about. All right, so character arrays are called C strings, as in C-S-T-R-I-N-G. So you can Google your chapter or over here for C string, all right? And what it's going to do is basically look at each character. All right. And then, of course, so that means that you're going to need a pound include space less than C string greater than. You might also just be able to use string and maybe string includes C string. So you can do it that way if you prefer. But if it does not work, then just change the pound include to C string. All right. So you know that one word that they're going to be doing is jump. All right. So jump. We got that one. Let's do number 2 now. That's aerospace. Like my older son's first word of his major in college. Remember, it was aerospace engineering. So aerospace in little letters, and you're going to output that in aerospace in capital letters. This is a very, very, very easy program. All right. Okay. So I probably won't be demoing that. but I didn't want to do character strings anyway. So in terms of lines of code, that's probably no more than 12, maybe less. Okay. All right, that's 8.5. And then 8.6. Let's see. I don't normally do this, so I don't know why I'm showing you all this now. History teacher at your school needs help in grading a true-false test. The student IDs and tests. Okay, so this is so you actually have another, this is the text file. So you have another file, chapter 8 underscore ex6 data.txt. Remember, that would be, again, the in file. I'm not reading whether you have to create an out file, but either way, so they're giving you in this thing here, history teacher at your school needs help in grading a true-false test. The student's IDs and test answers are stored in a file. The first entry in the file contains answers to the test in the form. Okay, so this first line of code, or the first line, excuse me, the first statement line in the text file are the test, like the answer, the right answers. So TTFT, meaning true, true, false, true, false, true, 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 false, true, false, true, false, false, true, true, false, true, true, false. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's 20 tests, okay? 20 questions on the test. And that's what they said, that the exam has 20 questions and the class has more than 150 students. I only see 1, 2, 3, 4. Anyway, so that's the first part of it. And then every other entry in the file, these are the other entries. Okay, these are the other entries. So the first entry was the right answer. And then every other entry is the student's ID, right? So the IDs are numbers like this, or character strings like this, okay? Not a character string meaning C string now. I'm just saying, in other words, letters and numbers, okay? So these are the four, I can't do it that way now. Anyway, so A, B, C, D, E, F, A, B, C, A, B, C. Those four are student IDs. And then there's, anyway, so in this case, in number 2's case, he or she did not answer. So like they skipped the question and then skipped another question. So they're going to tell you what to do on it. So each correct answer is awarded 2 points. So if they have exactly these letters up above, the true false is up above, then all 20 are right. So they would get 40 points. And I don't know if they're going to tell you to do whatever here. So they're wanting this as a percentage, okay? So you're dividing right answers by wrong. So like with 20 questions, if you get all 20 right, then 20 divided by 20 is 100 in terms of percent. If you get 2 wrong, because each one ends up being 5, right? 5 points basically. So if you get from 18 to 20, 18, 19, or 20, 20 is perfect, 19 is 95, 18 is a 90, right? And then 80 to 89. Anyway, but you can do it by division. 19 divide by 20. 18 divide by 20. That kind of way. Right? I should pull up calc. Okay. So if you just have a traditional whatever, you're dividing 19 by 20. Okay. The answer is a 95, right? Meaning that. So you just divide the first number, I mean, how many right against how many total. Okay. And then so in terms of your work again, you can more easily do this with a case structure, meaning switch structure with case statements. 90 to 100 is going to be A, 80 to 89.99 is going to be a B. And you just before that though, because you're going to be looping through an array. The array is all the students here. So you're going to have them in an array, and then you're going to be scoring. So in the case of student number 2, he or she missed 2 for sure because they left them blank. Oh wait, here's the more instruction. Each correct answer is awarded 2 points. So that's why I was saying 40. I knew there was 2 somewhere. So that's 40 points. So rather than 20 out of 20, you're going to divide the number of points possible, which is 40, right? Because the best you can do is get 20 questions right. And if you get each one right, they're 2 points each. So it's 40 points, sorry. So 40 is what your second division part's going to be, like 38 divided by 40. Okay. 30 divided by 40. And in the case of the 38, that's a 90. The 30, that's a 75. 20 divided by 40 is going to be a 50, whatever. But you've got to do the calculation of points based on if it's correct, meaning let's say if this T is correct here, which actually I can't tell because this one here, well, the first one T. So they're all, everybody got T right. Then the next one's a T. This one got it wrong, but instead of getting just 1 point off, they get 2 points off because each correct answer is 2 points. Each wrong answer, you still get a point if you get a wrong answer. So if you just answer them all, you're guaranteed a 50 is what this test means, okay? And no answer gets 0. So that's part of your little calculation, but that's an easy thing, right? And then you're going to be looping through your array, looking for those scores, and then you're not asked to get an average score or anything, so it's just that, all right? So that's not too hard either. All right, anyway, so I'm not sure which ones I'm going to do, but for sure 8.2 and 8.3 I will be doing something, and then I'll have one more example similar to one of the others. All right. Okay. Sorry about that long part there. Now I'm going to want this up, but later, I think. So first, let me pull up my PowerPoint. Okay. Slideshow from the beginning. What's going on? Did I not? Uh-oh. Oh, got to play it. Okay, so chapter 8, 3 sets of objectives. In this chapter, you will learn the reasons for arrays. Well, the primary reason for declaring and using arrays is to capture many, many, many variables, but all with the same name. So let's again look at tests, like that previous one was tests. Okay, so tests 1, tests 2, tests 3, tests 4, meaning if you've got 4 or 5 different tests, but they all have the same variable name, but they all have a different index or subscript of the variable name because it's a structured data type. So rather than having to declare double test 1, double test 2, double test 3, double test 4, in this class is only 3 though, right? So let's say double test 1, double test 2, double test 3. I could have double test, left bracket, right bracket, and put 3 in between. And that means in between those, the left and right bracket. And that means there will be a test 0, a test 1, and a test 2. But they're each tests, and I only have one variable, test, but the variable has an element based upon going from the first element, meaning the first test, to the last element, meaning the last test. And it can vary. So my gosh, arrays are just huge just for that one little reason. Then if you're doing, like when we had a program where we were doing, I showed you doing something about getting gas. How many fill-ups? What was your miles per gallon? What was the price of gas? What was the cost of each fill-up? Doing that with an array would make the loop that we used work even better and with less variables because they're all the same data type for each category. So you don't need to have a whole lot of extra stuff. So arrays are very, very good because they're structured. They're not simple data types. And structured means they all have the same data type that was declared, meaning double or int or string. But you can literally have 1,000 or 10,000 or 1,000,000. Amazon probably has 100,000 products, probably. And that's an awful lot of variables, right? But with arrays, no matter what it is, of course, they would have, sub arrays to capture different things. Like food things may have an F and then whatever. Clothes might have a C and then whatever. Things like that anyway, right? Because you have to account for all this data. But using an array makes the processing much, much easier, okay? And you use them primarily with loops. So it's really chapter 5 and chapter 8 working together, but you're also, in the case of the programming exercises, using the functions. And again, functions, I've told you quite a few times, are widely used in the business world as well. So they're important to use with programming to understand, it just captures little bits of code that you can then reuse. We call them snippets of code over and over and over again. So you're using functions in this chapter, you're using loops in this chapter, again, unit 8, sorry, and you're using arrays. All right. Explore how to declare and manipulate data into arrays. I will show something from the ebook. I wrote the page down here. Hopefully I'll find it after a while. I think it's 523 or 526, where they're showing you an example, and I'll kind of review that and elaborate rather than go through all these slides, because it's just going to be a lot. But again, here as always, I'm going to talk about them without really going into them. And this time I may not even get halfway through this. I'm going to just do what I feel I can with the amount of time I've already used, and to hopefully make the video no more than 1 hour. I'm guessing I've been doing this already a half an hour, but I'm not sure. But anyway, all right. So arrays, why? Because they can hold, one variable can basically have 1,000 different elements, but all with the same variable name, okay, meaning array name. Explore how to declare and manipulate data into arrays. So in the case of just putting in a declaration for an array, I know in the book, as I was reading through Unit 8, they had the first example they did was int, meaning integer, obviously, int list, left bracket, right bracket, and I think the number 10, and then a semicolon, because, you know, it's just declaring an array, in this case, an integer array, array name list with 10 elements. So the left bracket after the word list, then the right bracket after the number 10, and then a semicolon. Means you're creating an array with 10 values from 0 through 9. That's what that means, okay? And that's how easy it is to declare. And it's also very easy to manipulate data into arrays with for loops. And I'll obviously show a for loop on either 523 or 526. And then there's another good page that they refer to. Well, I had to look it up to find it, but I think it's 536. So I think it's 523 and 536. Write those down if you have a pen. 523 meaning page, and 536 meaning page in the e-book from that blue book icon on the right side of the screen in Mind Tab. All right. All right. Understand the meaning of array index out of bounds. So there's no catch, by the way, in C++. Not there is a catch, but there's no way to code for array index out of bounds. They don't have such a thing in C++. But what you have to understand is that the array index out of bounds won't happen as long as you declare your loops correctly, and that you understand that every array needs to be composed of positive index numbers, positive integer numbers, say, okay? So positive numbers, and positive meaning 0 or higher, not -1 or lower. So it has to be 0, and it goes up to, again, the number of values. -1 is the top value. So array index out of bounds occur if you get a minus number. The only way you can get a minus number is if you mess up on, let's say you're doing a for loop, or a while loop actually, and instead of doing an increment, meaning counter plus plus or loop plus plus or index plus plus or whatever, you're doing a minus minus. Or you're not accounting for stopping, because it is okay to do decrements, meaning going backwards, as long as you understand you got to stop when you get to 0, okay? And you can never start below 0. So that's it. And then you can't have a index value higher than the number of values -1 that are in the array. So you have to use programming logic to make sure you do not get an array index out of bounds. Otherwise, C++ can't handle it. All right. Learn how to declare and initialize arrays. Well, so to declare an array, I just said literally int list, left bracket, 10, right bracket, semicolon. That would be declaring it. Initializing arrays, you do not have to technically initialize it. So I could have just said int space list, left bracket, right bracket, semicolon, with nothing in between the brackets. That would be no initialized, not an initialized array. And then I can assign it via another value that I would put into it if I'm using function arguments. Okay. And there's an example in the book showing that as well. So that was declaring and initializing. Become familiar with the restrictions on array processing. Basically, on array processing, similar to some of the other chapters that we've gone through, there are restrictions based on what you can do with C++ and any particular programming aspect that we're dealing with. So you have to make sure that if you're trying to, as an example, if you have an int list, okay, with the 10 values, or you have a list, something else with X values, if you're trying to assign those values to another program, to another array that you have in your program, you can't just do it with, in the case of the int list 10, if I put the actual values in there, and then you can't put those values directly to another. You have to do it by a loop. So the key is, when you're talking about becoming familiar with the restrictions, make sure you're using a loop if you're trying to send or copy information from one loop to another, okay? Discover how to pass an array as a parameter to a function. So if you have a function and the function has a, like, let's say, array size element, meaning as one of the required arguments, assuming there's 2 arguments, it could actually be 1. So if you have a size argument in a function, you can assign that function, you can assign that array argument size, which whatever the size is, to a function from a constant that you've already declared, okay? And then how to search an array. Well, you're going to be searching arrays for sure in this chapter. You're going to be looking at, in the case of anything with a string, you're going to be dealing with, either C string or the string library, and then you're going to be comparing. In the case of the smallest index, which I said was programming exercise 8.2, or the largest index, which I said was 8.3, you're going to be comparing index values. Okay, that's how you search. You're going to compare. Again, in the case of list, so let's say list 0 versus list 1. So how would you compare it? Well, you'll be in a loop. You'll either be in a for loop or a while loop. And in the for loop is the way I would do it. In the for loop, you would then compare if list 0 less than list 1. And when I say list 0 and 1, I'm saying list left bracket 0, right bracket, then less than list left bracket 1, right bracket. That would be an if logic expression, right? Logical expression. And then if it is, then you're going to carry list 0 to the next comparison, which would be for list 2. And then the smaller of those two, you'd compare to list 3. And you don't have to type it, though, 100 times. You type it once. And all you're doing on the list 1, you don't really put list 1. It's list I or list X or whatever you do. You put in your for loop. Remember a for loop? You have 3 arguments, right? Or 3 requirements in the loop. The first value is the initial value. So that ends in a semicolon. The next one is how high can it go? That ends in a semicolon. And then the next one is, just incrementing your counter. So if you always start at 0 and then you're going incrementally through the loop, then the comparisons, just one statement of that comparison is going to compare 0 to 1, and then the smaller of 0 to 1 to 2, and then the smallest of 0, 1, or 2 to 3. But each time it's only 2, because each comparison there's a winner or a loser. If it's not less than, though, remember, it could be less than equal, but we're looking for the first, so we wouldn't care about that. So we would only need to do the comparison based on the less clause. All right. So anyway, that's what we have to basically do, and sorting them would work out that way perfectly well. Auto declarations, it's just, again, one of these caution things. They don't like us to do anything where we're making implicit. Remember, implicit means things that are done within C++. They just want us to be very careful. So on our declarations, obviously, we want to make sure that our declarations refer to everything that we're doing. If we don't put in values, and that's where they're specifically going, meaning we're not initializing an array, then just be careful, because what will happen with those values afterwards is the reference that you're putting on them from a variable might not agree to what your array was made on. So it's better to always do everything within the array, but sometimes they have to demonstrate to us how to do something where we did have an empty declaration, meaning an empty array, and how we would add things to it. But it's not that big of a deal. And learn about range-based for loops. Again, that's going to be based on taking 1 or 10,001 items. Very simple. And the for loop is going to go through it all for us. And C strings, I told you, were character strings. Character strings are used when we're wanting to do things. And typically, by the way, C strings are used with what we call multi-dimension or two-dimension arrays. And the best way to describe a two-dimension array is when you're thinking of in the old days. And you guys are too young to know this, but when I was young, if I wanted to go somewhere, I carried a road map with me. And the road map, I would have to periodically look at the map. Oh, okay, there's a town in about 22 miles or so. Okay, I'm going from, let's say, Toronto to New York. Oh, okay, so the distance is about 382 miles. So how am I going to go there, right? And then you can look through different ways to get in, to do it. These days, it's all obviously, well, first we went to GPSs in our cars, and now with our phones, nobody even uses a GPS in their cars hardly anymore. But anyway, point being, so you'd have a destination city and a from city. And where the two meet, meaning like a row and a column, that would be the number of miles between the cities. So you'd have the same cities listed in a columnar fashion. Let's just say as an example, New York, Toronto, Montreal, Chicago, Miami. We'll just say those, okay? So you'd list them from top to bottom, but then you'd also from top left to top right list them going the other way. So Toronto, sorry, I said New York, Toronto, Montreal, something, Miami, whatever that other one was. And then where they meet up, in the cell, that would be 0, because that's where the distance between Toronto and Toronto is a dash, right? Because I mean, well, Toronto is Toronto. The difference between the distance between Miami and Miami, again, would be a dash or a blank, right? But that's in the old days what we did. But that's how you can think of a multi-dimensional or a two-dimensional array. But ironically, we do use the C strings a lot C strings have to use two-dimensional arrays a lot because you're getting two different values, because as you're searching for things, you're dealing with the substring off that particular string. So it's a lot of stuff, but I wasn't going to touch it. Now I may, based on one of the programming exercises that I mentioned, 8.4, I think I said. All right, so examine the use of string functions to process C strings. Again, C stands for character strings. Discover how to input data into and output data from a C string. Learn about parallel arrays. Parallel arrays you're dealing with when you have two different columns of data. It's really called like table data. Whereas an example in one of the programming exercises I mentioned, they had test scores like true, false, true, false, true, false, true, 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 false, false, true, true, false, whatever. And then they had student ID and his or her test grade, or how many, how they entered all those values. So a parallel array is when you're using, in that particular case, a student ID with the scores for that student, and then comparing those to the first row of that in file, that text file, to see how they ultimately scored on the test. So that's what you do with parallel arrays. And manipulating data in a two-dimensional array, I didn't mention manipulating the data, but I mentioned that two-dimensional arrays are basically like you have a column and a row. So you can think of it as anything that you do with Excel too, where the letters in the cell are the letters in the cell are columns in Excel, and the numbers in Excel are for the rows. And where a letter meets a row, you have a cell. So like cell C2 in Excel talk is column C, row 2, right? So that's a two-dimensional array. And I said in the old days, the best example really to give is in the old days and using maps. And what would be in these two-dimensional arrays in an old map? Well, you wanted to know how far it was to go from Chicago to Toronto, or Toronto to Miami, or Miami to LA, or Memphis to Vancouver, BC, or Seattle, or whatever, just that kind of stuff. All right. And multi-dimensional arrays, they can go a lot more than just 2 times 2, meaning you can have a 3 by 3, a 4 by 4, and they get hairy when they're that big, but you won't have to do any of that in this class. All right. So simple data types. Variables of those types can store only one value at a time. Again, an integer, a double, a string. All these things are simple data types. Structured data type, a data type in which each data item is a collection of other data items. They're all part of list. They're all part of number. They're all part of class. They're all part of product, anything at all. And then we just, be it with our programming common sense, add the 0, the 1, the 2, up to 3,032 or whatever number of products or employees or books or whatever that we have, okay? And it makes the assignment of those variables so easy, right? Because you just pick the name you want for basically the object. So in the case again of list, well, that's pretty generic. It's not really much of an object at all, but they told us it's going to be for inputting numbers. I would rather just say number, right? Like number 0, all the way up to number 3031 or whatever, and go from that perspective. But as long as you understand, though, that an array is a data type in which each data item is a collection of other data items. They're all based on the data type of the array. So it's a double, it's an int, it's a string, that kind of stuff. All right, so an array, a collection of a fixed number of components, all of the same data type. One-dimensional arrays are what we're going to be doing primarily in this class, and probably on the test, I'll have to verify, but probably on the test it would be one-dimensional array, meaning the chapter 8 or unit 8 part of the exam. But I will sure let you know when, as always, 5 days before the exam when I give you a practice exam. My powder drink is getting warm already because I haven't had very many sips. All right, so one-dimensional array, though, that's like a list, means it's just think of it as one column with X number of rows, and it's all the same data, right? So if you've got 43 employees, you can have an employees 0, then an employee 1, employee 2, all the way up to employee, whatever I just said, 42 or something, and go from there. So the data type, the array name, and then see it's a left bracket, right bracket, and then the semicolon. So the left and right bracket are required. You don't have to have the argument. That would be then doing what I mentioned with a empty declaration, meaning no values assigned, but then at some point you would assign the values, okay? That's why with arrays, it's easy for numbers to just explode, okay? So it makes sense to sometimes have empty arrays. It's no problem whatsoever, especially like you're reading data files, you're reading a file from Excel, you're reading whatever into an array, you can just go on literally forever is the bottom line, right? So it's okay to not have to guess and say, well, gee, I think there may be 200 items. You can leave them blank, and when you figure it out through the loop is normally the key. The loop is going to go through records, and it's assigning 0 through whatever anyway. So you take that number, that last number, max value or whatever you want to call it, and then plug max value right where it says int expression. It could be max value, okay? So you go from there. Int expression, any constant expression that evaluates to a positive integer. Remember I said that it has to be 0 or higher. Has to be 0 or higher. It can't be any lower because what is an int expression? It's going to be the value of the first item in the array or another item that's in the array. So it can't be, technically it can't even be 0 because you have to have 1. But you can, when I say 0, it's because I said you can declare them as empty strings and then assign the value later. But either way, it can't be a negative number. It must mean, because otherwise you don't have any values. You have negative values. You can't have a negative, you can have a negative value, but you can't have negative, and I'm doing this in double quotes now, guys, negative products, let's say. Like, in other words, you have to have at least one product or at least 0 if you just have a field that doesn't have any, like a null field. So you could have a 0. But you can't have a -2 products. There's no such thing, okay? So it must evaluate to positive. All right, and then here they're just naming it int index, or the previous, now it's index expression, whichever. So the index is a non-negative integer value. Value of the index is the position of the item in the array, right? The position of the item. And then the left bracket and right bracket are the array subscripting operators. So some people call the indexes subscripts. Some people call them values. Some people call them, you know, whatever. But so subscripts or indexes are probably the two most common. But just remember your value within the brackets, and it has to be brackets, by the way. Now, if it's brackets that are empty like this one here, at some point you have to assign them. And when you initialize them, if you're going to be initializing them, you do that actually with curly braces, not the brackets, okay? So you only do the brackets when you declare the array or when you're calling the array. If you're going to assign an empty array, it has to be left and right brackets. And this is, again, when they were talking about some issues that you might have with, I forget what it said now. But anyway, if you don't do it up front, I was mentioning that you can have issues then because your data types might not match and certain values may not match. So if you then put in the values through an initialization statement, you have to remember that rather than brackets, they're now left and right curly braces, not parentheses, but curly braces. So there's always confusion. So here, the statement declares an array of 10 components. So list, right over here, this word list is what we're calling the array, okay, list. And then in list, there are 10, here's the declaration, int, so it's a numeric representation. Again, the list is the array, so data type, array name, and here is the number of values, 10. So if you have 10 number of values, the first one is 0, which means the highest one is 9. And remember, this is what also, this one, doing it this way will now show you a little bit better when I mentioned the index out of bounds. There's no such thing as list left bracket -1 right bracket. No such thing. There's no such thing as list left bracket 10 right bracket. So if you had a 10 or an 11 or higher, let's say 10 or higher on the right side, or -1 or lower on the left side, you'd get an array index out of bounds because it can't exist. There's no way you can have such a thing. So then the question is, well, how in the heck did it happen? Well, it happens when we make mistakes, right? When we make mistakes, normally it's that we're not paying attention. We have to be very careful with our programs. But just think again, if this is a list, even though it's numbers, just think though, list is the name, right? So that's the variable name, if you want to call it that. And each variable though starts at 0 and then goes up to the highest value that you might have. But technically that's like having 10 list numbers. So list 1, list 2, list 3, list whatever. But normally when you have it this way, it's because it's so much easier for you. Like if you're trying to figure out the maximum value, remember that 8.2 I said was the smallest index, 8.3 was the largest index. When you're just cycling through numbers, it's very hard if you're looking at 22 numbers to find to see without really staring it down whether one number repeated itself, right? Repeated itself. But you also, when you have it in this kind of fashion, you literally have one line of code to process it, and then you get a sum. Sum is going to be sum plus, and then list I, and then it'll be list 1, list 2, list 3, etc. So sum is just tabulating all along. Then you want an average. Well, average equals sum divided by count. You know what I mean? You're doing all this work, but this is all behind the scenes because of the array, right? Okay, they're also saying now you can assign a value this way. Then you might say, Professor, you said if we don't initialize it, we're using open and closing curly braces. And I said, and I did, and now I'm going to say yes, but all this is doing is actually assigning a value to a particular index. So which value is associated with the list 5? That would be a question if I was in class. And of course, it's 0, 1, 2, 3, 4, 5. So the 5th value here is really the 6th character or the 6th number in the list. So you could do list 5 equals 34. And you see there, it's assigning that value right here in list 5, which is the 1, 2, 3, 4, 5, 6th element, because it only goes up to 9, because it's based on 10. So just understand that logic, okay? All right. So then they're saying list 3 is 10, another example. List 6 is 35. And now they're saying list 5 equals list 3 plus list 6. You can also do that. Again, they had a couple statements about you have to be careful how you're doing, how you're manipulating the data in arrays. And I mentioned you can't switch from one array to another unless you have the values within it. Here you can. So in this case, list 5 will be able to be assigned to this number 45 by taking the 10, which is list 3, plus the list 6, which is 35. So 35 and 10 is 45. We all know that, but we're doing it here programmatically and saying list 5 equals list 3 plus list 6. So you can do that, right? Okay. Processing one-dimensional arrays. Basic operations on a one-dimensional array. So you're initializing, meaning you're declaring that, just like in that other one, int list left bracket 10 right bracket semicolon. So that's the initializing. Inputting data then would be where we're normally, and this is going to be the normally, and I'm going to show you an example of this in a few more slides, well, whenever I decide that we should move on and look at the page, because I don't want to spend, like I said, all the time going through this book, because through the PowerPoints, because I want to make sure. And this one, by the way, has, I think, 56 slides or 54. It's in the 50s, where last one, remember, was only 38. So there's quite a bit of content. So it's a matter of taking the most important content for what you're going to have to do for the chapter in terms of programming exercises, but also while considering what I want you to know for the Unit 7 and 8 exam on December the 9, 16 to 14. So December 14 is your final exam. All right, so anyway, but we initialize, then we input the data, then we output the data stored in an array, and we find the largest and or smallest element. So this part right here is part of 8.2 and 8.3, right, which I already said. Each operation requires the ability to step through elements of the array. How do we step through an array? We're going to do it using a loop, no doubt about it. Okay. So if you have now this int list 10 is now listed as int list 100. So you know 100 means that's the array size. That's how many items you have in the list. You know it's an integer, so it's going to be a whole bunch of numbers, and they're whole numbers. So that means you have values from 0 or sub-indexes, or index value, or subscripts, whatever you want to call them. You have 100 of them. The first one is 0. The largest one is 99. But that doesn't mean the numbers. Remember, this is the variable names. It's an array because it's got a left and right bracket. So it means we have 100 variables of type int, data type int, and these are the index values. Index values just means, in effect, the variable, okay? The variable values. So int I, and you see here in the loop, it's going to start at 0. We're going to go till it's less than 100 because 100 means 99 because it starts at 0. So 0 to 99 is 100. If we said less than equal to 100, again, it'd be subscript out of range. So it couldn't work. If we started at -1, even though we wouldn't, I mean, obviously, but if we did, it'd be a logic error, and again, we'd get a syntax. It'd be a syntax error. Sorry, not. I mean, it would be a logic error, but it would be a syntactical error too, because it has to be from 0 up to a number, and the highest number must still be in the list. Okay, and in this case, less than 100 means 0 to 99. And if you add 0 to 99, it is 100, meaning because 0 represents something. So we're A-okay. So anyway, we're starting at 0. We're going to less than 100. There are the two. Remember, you need semicolons. And then the last one is just your incrementation, because you want to go to the next value. And see here, it's C input. So in other words, the user is going to tell us these 100 numbers. So he or she is going to be literally inputting 100 numbers. Okay, so that is the way that's done. Refer to example 8.3 in the text, okay, which shows how loops are used to process arrays. So I'm going to now get out of there, minimize that. 8.3, I think I said, and I know I said 523 or 526. I want over here, full book, okay. 523. Let's see, do I need to make this bigger? We can actually, you know what? Let's see if when I'm on here. Let's make this bigger here. Okay. Sorry about that. All right. So anyway, in this thing here, let's look at what we've got. Let's see, 23. Oh wait, no, that's not it. Go to 523. That's where I said. Okay, so this is an example. They're telling us the user input is in shade. So enter 5 test scores. They want us to enter 5 test scores, okay? And we put in 78, 87, 65, 94, 60. Just the way we learned about doing it in loops. You know, obviously the loop includes a little double space and then the same number, the next number, and then double space the next number, etc. But you can also just do 78, enter, 87, enter, 65, enter, etc. But either way, then all we're doing with the loop, remember, we have 5 different test scores, but it's one variable. Call it test 0, test 1, test 2, 3, and 4, right? Nice and simple. The average score is 76.8 because it takes them all as they're coming, and we do sum equals sum plus index or whatever our the little variable name is. And then if we're looking at each number, like 65, we want to compare that against the average. So because the average score is 76.8 based on the math, just adding these 5 numbers up, divided by 5, and you know your program can do it faster than we can, even though we're all proud of ourselves. So let's go ahead and do it. So I'll say 70, 150, 210, 300, 360, 364, 369, 369, 376, and 8, 376, 384. 384 divided by 5. Well, 570s are 350. Now there's 36 left or 38. I'll say 36 if I'm either right or wrong, but we know the first one's 70 now. So 5 6s are 30. Well, that's up to now 80, but it's not up to 86 or 88 or whatever. So that gets us up to 76, but there's the fractional part left. So, you know, anyway, computers do it much better than we do, right? So in this program, they want to do the output to show the average score. And then if any particular score is less than the average, they want you to say 60, you know, the score is less than the average score. So obviously, you see, like 78 doesn't show up because it's not less. 87 is not less. 65 is less, so it shows up as 65 is less. 94 is not. 60 is not. We could also have done it where we got the average, and then we want to know, well, who made better scores than average, right? Everything can work both ways. So you can see this program here, and that's the user input. And then we want to just look at what we're doing. So the program works fine. However, if you need to read and process 100 test scores, you would have to declare 100 variables. See, because we're not showing the work done yet. This is, again, chapter 5 based, right? A loop based. That's all we're doing. But we don't have anything in terms of variables to show the benefit of having an array. So the point was showing that this was done earlier. So program works fine. However, if you need to read and process 100 test scores, that would darn well be harder, right? So we said we would have 100 variables. We can write many CIN statements, COOT statements, and if statements. Thus, for large amounts of data, this program is not efficient. Meaning, again, going back to chapter 5. If I went above that, it says this is a chapter 5 version of, you know, going through loops. So note the following in the previous programs. We'd have to have 5 variables declared because test scores less than the average need to be printed. All test scores are of the same data type, int. The way in which these variables are declared indicates that the variables to store these numbers all have the same name, except the last character, which is a number. All the if statements are similar, except the name of the variables to store the test scores. Now, 1 tells you that you have to declare 5 variables. Next, 3 and 4 tell you that it would be convenient if you could somehow put the last character, which is a number, into a counter variable and use 1 for loop to count from 0 to 4. 1 because remember, 5 because it's 0, 1, 2, 3, and 4. Okay. So that was that part. Then 3 and 4 tell you that it would be convenient if you could somehow put the last character, which is a number, into a counter. So we want the counter to go from 0, which is the first number, to 4, which is the last number. Okay. And use 1 for loop to count from 0 to 4 for reading. So that's just for reading. And another for loop to process the if statements. Because as we're going through these, we want to then know, even though we didn't say it here, right? Remember, this is just a sample of a program from really earlier in the class. And here we're showing, though, the average test score is that. But then this 65 is less than, 60 is less than. That's not coming as we're entering each score because we got to first get all 5 scores in. That then does this 76.8. So this average test score would be after the processing up to 5 things. But then you got to go through another loop to then compare first score, meaning again, let's call it test 0. Is test 0 less than average score? If it is, then test 1, or whatever I just said this is, test 0, is less than the average test score. But test 0 in this case, actually I shouldn't have said that, it's 2, 0, 1, 2, 3, 4. So test 2 is less than the average test score. Test 4, because it's 5 characters, so there's 0 through 4. Test 4 is less than the average test score. Program works fine, yeah. So let me just now go down. You please read this though. Oh, so I can go over and just kind of look at it. All right, so an array is a collection of a fixed number of, do I know I'm on 524? That's the problem with this thing. I never know if I go, because they don't change. Let me just see down this way. I'm not sure. Well, I'm not sure in all honesty which page I'm on now. So this didn't come out the way I thought it would. I'm going to look at my hard book because I have a physical book. Let's see, 523, I said. Let's see what they're doing on it. Oh, 520, stupid. Well, 523 did show an example, but 528 is actually what I wanted, which is not even 536. Okay, so on 523, okay, so before 523 is where I really wanted to go. So let's go back to 522. Put that back up here. So get rid of the 3 and make that a 2. Okay, so right here, we're there. They said this is a chapter 5. In chapter 5, you learned how to read numbers, print them, and find the sum and average. Okay, so this is a program we did. See, we literally declared 5 variables and another variable for average. Then we did the little set precision to make 2. Then we said enter 5 test scores, test 0, test 1, test 2, 3, 4, right? So they're going boom, 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 boom. Once we get all that, we're saying average equals test 0 plus test 1 plus test 2 plus test 3 plus test 4. And then divide by average equals test. Where in the heck is the? Where in the heck? Oh, all right. No, we're getting average, but we're not really getting average. There's something missing here. I don't want to skip over it. Anyway, so, but you know that obviously we need to have this here divide by 5, but I don't see that this goes over anymore. Let me make it wider this way and see. I can't. Let me make this bigger. Okay, yeah, see, it's dividing that by 5. It has to, obviously, otherwise we don't get an average. So average equals those 5 scores divided by 5. And then the average test score is average, okay? And then if test 0 less than average, test 0, that's what I mentioned a while ago, is less than the average test score. If test 1 less than average, same thing, 2, 3, 4, and also that's what we're doing basically, all right? And then this is where I started. Enter 5 test scores. The average test score is 76.80. 65 is less than, 60 is less than, the other 3 are above, all right? So then this stuff here is about what we had to do. You know, first of all, we have 5 if statements. Second of all, we have 5 different variables. How many of these we really need is a question, okay? And then in arrays, I'm not sure though actually if they show that thing right now. I'm going to go through it. Well, I guess, yeah, so here they're sort of talking about it. So we need a data type, right, which we want int, and then num5, but pretend it's test. I don't know why they didn't say test here too. But anyway, num5. So declares an array num of 5 components, each is int, and then num and 0, 1, 2, 3, 4, all are integer though. All right, so that's what we have here. So just pretend it's those 5 test scores, okay? To save space, we also draw an array as shown in figure 8.2. So here we're just saying num 0, 1, 2, 3, 4 for A, and then num 0, 1, 2, 3, 4 for B. So what are we saying in here? Say we also draw an array as shown in 8.2a or 8.2b. Either way, they're saying we have num, and then we have 0, 1, 2, 3, 4, or num 0, num 1, num 2, num 3, num 4. In the first one, I guess they're saying we declared them, but with the array, then it's with the num, and we're getting the built-in 0, 1, 2, 3, 4. thinks where they're going on that. Accessing array, but they're not really showing it. Okay, well, on my programming exercise, on example exercise on Thursday, I'll give you basically a good thing that'll help you on 2 and 3. But make sure you read this information, okay? So that's all that. I want to now see this. Actually, we saw this in the slides. So it looks like they skipped it. Dang it. Makes me mad. Makes me mad. Let me just go and see if processing one-dimensional array. We saw this too. So this is nothing. Yeah, they skipped what I wanted to show. Oh, wait, example 8.3. Isn't that what I said? I don't even know what I said anymore. I apologize, guys. Oh, shoot. Well, I'm going to go look until I see what I want. And oh, okay, this actually is what I want. This is the one I really wanted to show you. Okay, good. All right, so these are different ways of using loops for some things that you're going to need to do in this chapter, okay? So you notice E says largest element in the array, and this is exactly the code you would need to do a largest element in an array. Obviously, other than having, like, in this case, the array is called sales, okay? And then we're using max index. So sales is our array, right? And we're going to have max index, meaning because we want to start it at 0, and then sales to the index. And the index is, there's 10 items. So there's going to be sales from 0 through 9. And you see how easy it is to determine which one is the max. So if sales max index is less than sales of index, in other words, if sales of 0, okay, excuse me, is less than sales of 1, then max index equals index. That's an if statement. It's only going to go there if it's true, right? So if it's true, then we're going to assign index to max index. If it's false, then we're saying largest sale equals sales, max index. That's it. That little tiny bit of code there is all you need really to figure out what number out of a billion is the largest, if you want to type in all of them through a C input statements, okay? So here, again, how it works with an example. So suppose the array sales is given us in figure 8.6. So here's our sales. So remember we said there's 10 values in it. So sales 0, sales 1, sales 2, sales 3, up to sales 9 means there's 10 elements. So 1 is 1250, 1's 835. This is now the actual value. This is what I call the index, what some people call a subscript, but either way, it's sales, less than, left bracket 0, right bracket. But what matters to us is what the user gave us, or what the product list gave us, or what the database gave us, or what the text file gave us. And that's the numbers input for them, okay? So we have 10 sets of values. So in this case, to find out the minimum, which is the least, we'd want to compare the 1250 against 835. Is 1250 less than 835? Okay, we want to know which is the least. If 1250 is not less, then in this previous thing up here, we would come down to largest sale equals sales of max index if it's the largest. Otherwise, if it's less than, okay, then we're going to go down to the other. So max index in this case is the 1250, all right? So the first statement here, 0 is not less than 1, because 1250 is not less than 835. So we're then skipping, because this is false, and we're saying largest sale equals sales max index. Max index here is 1250, all right? So now it's going to be, is max index 1250 less than 19.60, which is the next index, all right? So max index is 1250. Is that less than sales index? Now it's 1. No, sorry, now it's 2, because we already compared against 1. So now it's not, because it is less than. Sorry, it is less than. So in this case, we go into the if, and now sales max index is 1250, is less than sales index. Index is 1960, okay? And because it's less, we're now going to say max index equals index, which means the current number we're on, okay? So same thing again, but now 1960 is the new high out of those three, and now we're going up against 25. So this one is less than again. So 1960, which is max index now, is less than sales index 3. Yes, it is. So now we're saying, oh, okay, well, max index is not 1960 anymore. Now it's 25. And then we go to the next one. This one is greater, so 25 is greater than 14. So it's not true here, so it skips it. And largest sale is sales max index, so it stays the 25. Now we're going up against 39.43. Well, 25 is less than 39.43. So again, max index is equal to index, meaning now 39.43 is the max. Okay. All right. Then we have 39.43. Is that less than 35.90? No. So 39.43 is still going to be the value. So max index is 39.43 still. Now it's against 35.90. Oh, sorry, that was against 35.90. So it's still 39.43. And now is 39.43. We're going against 98.23. Bottom line is it's going through the loop every time, right? Each time it's the current max index. Max index at 0 was 1250. The index, when it was max index at 1250, the index was 835, which was 1. 1250 was higher. I actually don't remember now if this one's doing largest. Yeah, it's largest element in the array. So this would be for 8-3 for you, not 8-2. But 8-2 then would be the, very close, obviously, if this is the max index that we're going to get. So this is the largest sale. Well, it would be pretty easy to do the same thing, but flipping your less thans to greater thans or whatever, depending on what we're trying to get when we're doing the smallest index. But it's still an equally small for loop like this. Okay. All right. So, and please though, finish reading that. Okay. Very good. So then at the end, it's going through all the values and it's saying the bottom line is max index equals 7, and 7 is this, which means it's the 8th value. 0, 1, 2, 3, 4, 5, 6. It's the 7th value. 0, 1, 2, 1, 2, 3, 4, 5, 6. Yeah, it's the 8th value, which means it's index value 7. Okay. And once it gets to 8 and 9, they're less than. So 98.23 is still the largest. That's why they stay at 98.23. So the sales max index is always the larger of the two numbers being directly compared. And 98.23 passed in this one. And then it retained its pass when it came against this number. And it retained its pass again when it came up against the last number of 35.64. Okay? All right, so please read that. And then another example. Enter 5. Okay, this was the one on the 5 test scores. So they skipped 3 or 4 or 5 or 6 pages. So here, remember, we had those test scores, right? So those 5 test scores, you can go back, 5 or 6, 7, 8 slides, whatever it is. I can't do that for us. It's just impossible to go through everything, but understand that, look at what all the loop is doing, okay? So here we now have test 5. Test left bracket, right bracket with a 5 in between. So that's declaring an array of 5 test scores. And then we want to know what the sum is. So it's always good to put the value for it, starting it with 0. We want to know the average because we also want the user, same test input from chapter 5, but now the same, with the same output. The average test score is 76.80. 65 is less than 76.80. 60 is less than 76.80 as well. But now it's done with this code versus no 5 if statements. It's 1 if statement. Okay. No 5 variables for test. It's 1, but the 1 represents 5 different values: 0, 1, 2, 3, and 4. Everything else is the same. Okay. So that's how that worked. All right. Okay. I really am going to stop. You know that I do have my diabetes. I feel like I'm getting weak right now. I do apologize for that. But I also know this thing has been going on probably an hour, and I really don't like them to go more than 40 or 45 minutes, but it's just so hard. But understand that I only covered about 15 slides, literally. Okay, now I know you might say, well, actually, you're only on number 12, but I talked about some of these things in here as well. There's the sales. Oops, sorry. But whatever this value is, it is. And then saying what we're doing with them. All right. I'll go through maybe 3 more slides just to go through. So arrays can be initialized during declaration. And I mentioned this when I was still on slide 1, 2, or 3, where I said, say if you have an initial value. So here we have a double sales 5. All right, that is declaring an array. But I said if you assign the values, you're doing it via open and closing curly braces. So you're separating them all this way. And that's the same as saying if you want to do an empty declaration, so double sales with nothing in between and then equals. So you can do it this way, or you can do it this way. They're both the same, but they're using curly braces, which are not preferable, but you can do that. All right. Partial initialization of arrays during a declaration. So in this case, we're saying an int list of 10 equals open and closing curly with 0. What that means is you haven't declared any values, so every one of them will have the value 0. Well, technically you did say 0, but this 0 means apply it to list 0 all the way up to list 9. Okay. Another one, int list 10. Again, int list 10, but we're only giving 8, 5, and 12. And again, they're in these curly braces. So that means list 0 is 8. List 1 is 5. List 2, let me say this again, sorry. All right, so list 0 is 8. List 1 is 5. List 2 is 12. Okay, but it was a list of 10, which means we have 3, 4, 5, 6, 7, and 8, and 9 to go, and they're all going to be zeros. Okay, so let's see if they show it. They don't show it. They don't show it. But anyway, declares an array of 10 components and lists 0 and initializes 0 to 8, 1 to 5, and 2 to 12. And then, yeah, see, all the others are 0. So if they showed list 3, list 4, list 5, list 6, list 7, list 8, and list 9, they would all be 0 because we only initialized 3 of the 10. All right. All right, guys, I'm going to stop for now, but anything that we need on these other slides relative to your programming exercises, I'll come back and talk about things in the way I normally do it anyway, which is obviously through my examples. So on Thursday, for sure, I'm going to cover 2 of the 6. That's pretty darn nice. And then I'll cover one more next. Let's see. So that's Tuesday will be the overview. Thursday will be programming example 1, which will demonstrate 2 different programs though. I mean, 2 different programming exercises. It's going to help you in that regard. And then next Tuesday, I'll have another one that'll either cover C string, meaning character string, or it'll cover a in file and out file, or there may not have been an out file, sorry, but an in file anyway, and then doing whatever. So it'll be one of those 2, I think. I have to look at it again a little bit later. All right. Have a great day. I apologize that I'm getting a little, little blah blah right now, but I did start by going through things I don't normally do, meaning I actually pulled up programming exercise 8.1, then 8.2, 8.3, 8.4, 8.5, and 8.6. So I had to show you a little bit of them. And 2 and 3, I said for sure I'll do. 1 is also going to be in consideration. That was the one that had 50 numbers from 0 to 49, and for the first 25 of those, you're going to square them, meaning take, let's just call it number 0 through number 49. So for the first 25, that means number 0 to number 24, multiply whatever the value is, the 0 by 0, the 1 by 1, the 2 by 2, the 3 by 3, all the way up to 24 times 24, and then output those numbers. But as part of that, then the next 25, though, we're just multiplying the number of itself. So 25 through 49 times 3. Got to go, guys. Got to go. I'll see you tomorrow, though. Have a great day. All right. Bye. Let's see over here. In here, stop my recording.